Dear students, in our last lecture, we discussed about KCL and nodal analysis. In that lecture, we covered one numerical also with one junction apart from the reference junction, one principal node apart from the reference node. Now, in this particular lecture, we will take up one more numerical in which we have more than one principal nodes apart from reference node, reference junction. And we will see how to solve such network using nodal analysis. So, now this is the numerical. In this numerical, we have been asked to find out the voltage at junction 1 and 2 in the given network using nodal analysis. And hence we have to determine the current also in the 10 ohm resistance which is connected between these two junctions, means junction 1 and junction 2. So in this network, now let us see, we have two active elements. We have one, two, three, four passive elements, and then when we have a number of nodes, but when we say these two are the junctions and this one is the reference node, right? This is a bilateral network, so the direction of current in any branch won't make a difference in the response of the given network. So let us solve this network using nodal analysis. Now, first thing that you will do is identify the principal nodes apart from the reference node. So let us assume that these nodes are, or these principal nodes are 1 and 2. Now second thing that we do in nodal analysis is we assume some voltage on each of these principal nodes which we have identified, and let us say V1 is the voltage at node 1 and let us say V2 is the voltage at node 2. Now the third thing is take current on each of these junctions 1 and 2. Okay, assume the direction of these currents now, because it is a bilateral circuit, so the direction of current in any element does not matter. So let us draw this circuit here once again. So there we have resistances and this is a voltage source, and this is one resistance, this is again one resistance here, and then this is your current source. This is a current source, right? And this is some, let us, the value given is 4 ampere, and here the value given is 20 volt. This is 5 ohm resistance, 10 ohm resistance, 20 ohm, and this is also 10 ohm. Now this is the reference node, so it is kept at zero potential. This is 1, so let us say V1 is the voltage here, this is 2, let us say V2 is the voltage here. Then we will take some current here. So the direction of current does not matter in bilateral circuit. You can take any direction, guys. You can either assume all the currents are coming to each junction. You can either, or you can assume that all the currents are coming out of the junction. It is totally up to you. You can assume this direction also. All the currents are coming out of this junction. The direction of current does not matter, right? Then here, in this, we will write. Now, this was, first of all, what we did, we have identified the junctions, principal junctions, apart from the reference node. There are two principal junctions. We have given some marking to every junction, 1 and 2, let us say. We have assumed some voltage at each junction, V1 and V2, let us say. Then we have taken the current on each junction. You can take any direction of the current across the junction, that is up to you, right? Now we'll give some marking here. Let us say it is I1, it is, let us say, I2, it is, let us say, I3, it is, let us say, I4, it is I5, and it is I6. Okay, so we have given some notation to each current. Now we will apply KCL. Apply KCL at each of these junctions. Okay, so the KCL equation of junction 1 is, now what does KCL state? KCL states that the net current entering a junction is equal to net current leaving the junction. Okay, so according to KCL, okay, total current entering a junction is equal to total current leaving that junction. Now let us, the KCL equation of junction 1 is, so I1, okay, it is 0 because no current is entering the junction. No current is entering the junction here. All the currents are leaving the junction. So it is 0 is equal to I1 plus I2 plus I3. Similarly, we'll take the KCL equation of junction 2. So let us see. So at junction 2 also all the currents are leaving, but no current is entering here. So it is like 0 is equal to I4 plus I5 plus I6, right? Now, if you have seen this particular branch, this one, sorry, this particular branch here, this one, this is the common branch basically, and you can see I3 and I4, you have assumed, this is totally assumption, it is totally assumption, right? So they are opposing each other, so you can write here, okay, you can write here now, but I4 is equal to minus I3. So you can replace it in this equation. So you'll get minus I3 is plus I5 plus I6 is equal to 0. Or I5 or I3 is equal to I5 plus I6. So this is, let us say, equation number 2 here, for example, not 1. 1 will take up here. So here you can simplify this equation. You can write it like this, or I1 plus I2 plus I3 is equal to 0. So this is equation number 1. Now this is the KCL equation of each junction. Okay. Now in next step, what we will do is, okay, so after the KCL equation, we will obtain the V by R of each current as assumed, right? So in that case, I1 is equal to, now how will we take I1? Now let us come back to the circuit diagram. So I1 is moving from V1 to this particular 20 volt and like this. So that means if I1 is moving from junction 1 to the battery, that means your V1 is at high potential. Okay. Do not get confused. V1 is at high potential because you have assumed that the direction of current is from V1 to 20 volt, right? So what I will write? I will write I1 as V1 minus 20 divided by the resistance of that branch, which is equal to 5 ohm. So 5. So this is one thing. So guys, similarly, we can write the V by R equation of I2 and I3. So let us see here what is written. I2 is equal to V1 by 10 and I3 is equal to V1 minus V2 by 10. Now let us go back to the circuit diagram. Now I2 is flowing from junction 1 to the reference junction. So this is how I2 is flowing, and I5 is also flowing the same manner, right? So it is V1 minus, so there is nothing in between, no voltage source here. So this is at zero potential, this is at 0 volt here, reference node. So V1 and then nothing is there. So V1 by the resistance means V1 by the resistance, which is 10 ohm. Similarly, I3 is flowing from V1 to V2, means junction 1 to junction 2. So it is V1 minus V2 by 10. Okay. So in the similar manner, we can also write the equations for the junction 2 and their equivalent V by R of each current, right? So in that way, we will get I4, which is equal to V2 minus V1 by 10. And because I3 is opposite of I4 is opposite to that of I3, so we can also write it like this. This is totally up to us. And then I5 is flowing from junction 2 to the reference node. So it is V2 by 20 and I6 is minus 4. Now let us see why we have taken I6 as minus 4, because see, this current is directed in this direction. Okay, it is directed in this particular direction here, right? But what we assumed that the current is flowing like this. So this direction, which is assumed by us, is opposing the actual direction of the current, and that is why we have taken it as negative, right? So these are the equations. I have marked them as equation number 3, 4, 5, and 6, and 7, and 8. Now what we will do is, now sorry, we will substitute these equations in equation 1 and 2 wherever applicable. So in that case, your I1 will be, sorry, so at junction 1, and I'll write one thing more here. Let us say at junction 2, right? So at junction 1, we have I1 plus I2 plus I3 is equal to 0. So I1 is equal to V1 minus 20 and then divided by 5. Then I2 is equal to V1 by 10, and then I3 is equal to V1 minus V2 by 10 is equal to 0. So now we can, this is, let us equation number 3, 4, 5, 6, 7, 8, 9. Let us say this is equation number 9. Okay, similarly at junction 2 we have I4 plus I5 plus I6 is equal to 0, or we can also write I3 is equal to I5 plus I, whichever you find suitable you can use that equation, that is totally up to you. Now I4 is equal to V2 minus V1 divided by 10 plus I5 is equal to V2 by 20 and plus I6 is equal to minus 4 is equal to 0, right? So now this is lattice equation number 10. So, as in this, we got the two equations. So, these two equations are the algebraic equations you can see, which have two unknown parameters. So, let us go back to the circuit diagram and see. Okay, so our objective in the question itself, it was mentioned that we have to find out the junction voltages at 1 and 2, junction 1 and 2. So, now we assume that there is a voltage at junction 1 and there is some voltage at junction 2. These two are unknown parameters. These two are the unknown parameters, right? So these are unknown parameters, and hence from this whole analysis we can obtain these two unknown parameters. So we have now two algebraic equations as specified here. So we have two junctions apart from the reference junction. We have got two algebraic equations. If we have three junctions apart from the reference junction, so these two algebraic equations can be, these algebraic equations can be solved to find out this one 11 and 12 to find out the unknown parameters. Okay, uh, which are V1 and V2. So we'll write these two equations. So like here, so we'll simplify them algebraically. We'll get V2 is equal to 40 volt, and by substituting the value of V2 in equation 11, we'll get V1 is equal to 20 volt. Now our question was also that we also have to find out the current in 10 ohm resistance connected between junction 1 and 2. So the current is I3 or I4, because we have assumed both. So I3 is equal to V1 minus V2 divided by 10. It is equal to 20 minus 40 divided by 10. So So it is equal to minus 20 divided by 10. So it is minus 2 ampere. And similarly, if you want to find out I4, but because I4 and I3 are opposite, so you can find out I4 also. So I4 was V2 minus V1 divided by 10. So it is equal to 40 minus 20, because V2 is 40, V1 is 20 divided by 10. So it is 20 by 10. So it is 2 ampere, right? And or I3 is equal to minus 2 ampere. Now the negative sign only indicates the actual direction of the flow of current. That is it. So it has nothing to do with anything else. It only indicates the actual flow direction of the current. Okay, so this was all about the lecture. We have discussed a junction wherein we have one voltage source, one current source, two junctions apart from reference junction. So two unknown parameters means two node voltages, and we have applied the nodal analysis here to find out the node voltages and hence the current in a respective branch. So thank you so much, dear students.